Hello everyone, welcome to my new lesson video. In this video, I will be discussing the balancing of chemical equations or reactions. Here, I will discuss why is it important to balance a chemical equation and how to do the balancing of the chemical equation. I am your teacher, Sir Mark Laroya. One of the most important things in chemistry, aside from writing the chemical equation or reaction, is the balancing of the chemical reaction. But the question is, why do we need to balance the chemical reaction or equation? It is because we simply follow the law of conservation of matter, which states that matter cannot be created nor destroyed. Meaning, in a chemical reaction, the amount or the total mass of the reactant or reactants should be equal to the total amount of the products. Each of the substance involved in the reaction, their amounts should be equal to the amount of each of the substance involved or elements involved, same amount for the product. It's because it accounts for the total mass of the reactants equal to the total mass of the product or products. Next we will do now is the balancing of the chemical reaction. So let us now do the balancing of chemical equations. So we have here the reaction between methane and oxygen, and this particular chemical reaction is actually a type of reaction which we call combustion, wherein an organic substance like methane will react with oxygen in a diatomic form. That is why it has a subscript of 2, and then it will produce two products, the carbon dioxide and water, given or assuming that the combustion is complete. In balancing chemical reaction like this one, we said that we should preserve the number of each of the elements involved in the reaction. Same number of each element from the reactant side with the same number of each element also on the product side. Let us now balance this chemical reaction. So the reactant side, we have 1 carbon, we have 4 hydrogen, and we have 2 oxygen. While on the product side, we have 1 carbon, 2 hydrogen, and 3 oxygen. It's because you have 2 here and another oxygen here, that is why we have 3. So let us now balance the chemical reaction. So as you can see, both carbon are the same, that means they are balanced. But when it comes to hydrogen, we have 4 on the reactant side, but we only have 2 on the product side. So let us focus on the side wherein there is less amount of the element. So here in the product side, we only have 2. We have 2 because of the subscript 2 here of the hydrogen. So what must we do in able to make this number of hydrogen in the product side equal to the number of hydrogen in the reactant side? That is simply by putting 2 here like a coefficient for the entire substance or the entire compound water, H2O. So that means this 2 here will be multiplied to the subscript of hydrogen, making now the number of hydrogen equal to 4. So we can say that the number of hydrogen now is the same, or they are balanced. However, because of this 2 here, it affects the number of oxygen. So for water now, here we now have 2 oxygen. And aside from this 2 oxygen, we also have 2 oxygen here on the carbon dioxide compound. So that means from 3 and then we add one more oxygen, we have now 4 oxygen, making it unbalanced because the number of oxygen in the reactant side is only 2. So let us now focus on the oxygen on the reactant side. To make this oxygen equal to 4, same with on the product side, we must also put 2 here as a coefficient like for the oxygen O2, making this now equal to 4. So as you can see here, we have the same number of carbon for the reactant and product. We have the same number of hydrogen, 4 and 4. And now we also have the same number of oxygen, 4 and 4. So this is now the balanced chemical equation for the chemical reaction of methane plus oxygen producing carbon dioxide and water. You have 1 methane plus 2 diatomic oxygen. You have 1 carbon dioxide and 2 H2O. So let us now balance another chemical equation. This is actually a type of chemical equation which we call single replacement, wherein we have here a compound, aluminum bromide, will react with potassium, and this reaction will take place, okay, in an aqueous solution. Based on activity series, potassium is more active than the aluminum. That is why potassium can replace aluminum. The product will be, it's now potassium bromide and leaving the aluminum alone. So this is the single replacement reaction. So let us now balance this chemical reaction. On the reactant side, as we can see, we only have 1 aluminum, 3 bromine, and 1 potassium. On the product side, we have 1 aluminum, 1 bromine, and 1 potassium. So obviously, it's the bromine which is the unbalanced or not balanced in our chemical reaction. So let us now focus on the bromine on the product side. Now, to make bromine balance, we should multiply this 1 by 3 to make this also equal to 3. So our bromine now will become balanced, and that is by putting 3 here before the potassium bromide. So multiplying this 1 times 3, so you have now 3 bromine. However, because of this 3 here, it affects the number of potassium in our product side, making this now 1 times 3 as well equal to 3. So we now have 3 potassium on the product side and only 1 on the reactant side. So for us to balance this, on the reactant side, we should also multiply potassium by 3, making this now equal to 3. And that means we should put 3 here as the coefficient of potassium, making now our chemical reaction or equation balanced. So this is the balanced chemical equation of the reaction between aluminum bromide and potassium, producing 2 products, the potassium bromide and aluminum. So for our last example, let us now balance this chemical equation. So this is actually a chemical equation or reaction which we call neutralization. So neutralization is the reaction between an acid and a base producing salt and water. So for acid, we have here carbonic acid, and then for base, we have the sodium hydroxide. When these 2 react, they produce 2 products, the salt and water. Salt in the form of sodium carbonate and water H2O. So let us now balance this chemical reaction. On the reactant side, we have 3 hydrogen, 2 coming from the carbonic acid and 1 from the base sodium hydroxide. For the entire carbonate, we only have 1. There's 1 carbonate here. And then for sodium, we also have 1. And for oxygen, we have 1. On the product side, as you can see, we have 2 hydrogen in H2O, 1 carbonate here from our salt. Sodium, we have 2, the subscript of sodium in our salt, Na2CO3. And then lastly, we have 4, or rather we have only 1 oxygen, that is right here in water. So let us now balance this chemical equation. First, let us balance the hydrogen. Okay, or I think it would be better, I prefer to balance first the sodium. Okay, so as you can see, we only have 1 here in the reactant side and 2 on the product side. So let us focus on the sodium here on the product side. To make this equal to 2, same with the number of sodium in the product side, we must put 2 here. So we will now have 1 times 2 for sodium, making this equal to 2. And now we have a balanced sodium. But this 2 here affects the number of oxygen and hydrogen in the entire reaction, which means in the reactant side, this will also be multiplied by 2, making this equal to 2, and our hydrogen, making this now equal to a total of 4. So 2 hydrogen plus another 2, so simply add 1, we have 4. So looking now on the product side here, to make hydrogen equal to 4, to make this equal to the number of hydrogen to the reactant side, we must multiply this by 2, making this also now equal to 4. So we have now a balanced number of hydrogen, and also this 2 here will be multiplied to oxygen, making this now equal to 2, which is now also the same as the number of oxygen in our reactant side. Making this now the balanced chemical reaction of our neutralization, the reaction between carbonic acid and sodium hydroxide, producing sodium carbonate and water. So that is how we balance chemical equations. So thank you very much for watching this video. I hope you learned something new in chemistry, most especially about balancing the chemical equation. So please don't forget to like and share this video to your friends and classmates. And don't forget to subscribe to my channel, Sir Mark Araya. Again, thank you very much and see you again next time. God bless.